Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 30th, 2025, about 2 days ago. This paper introduces GR-Dexter, a full hardware model and data framework that pushes vision-language action policies beyond simple grippers to bimanual, high degree of freedom dexterous hands, while improving robustness to unseen objects and unseen instructions. The paper is titled GR-Dexter Technical Report. Alright, and as we will see later, the combination of teleoperation data and cross-embodiment training makes the real-world results especially compelling. Figure 1 explains why GR-Dexter generalizes. The model learns from a mix of data sources, not just robot demos. This figure shows the full pipeline, with 4 inputs at the top flowing into the GR-Dexter policy in the middle. Cross-embodiment data means demonstrations collected on other robot bodies, which helps transfer skills without matching hardware exactly. The bottom row then grounds this in outcomes like makeup decluttering, tool use with tongs, vacuum handling, and pick and place. Figure 2 makes the key claim feel concrete because it shows the same policy handling long sequences, new objects, and new language. The full panel set in Figure 2 summarizes 3 capability buckets in one place. The top strip focuses on long horizon skills, with multi-step household routines like serving with tongs and decluttering. The middle strip highlights unseen object grasping, which is the model transferring grasp habits from cross-embodiment robot data. The bottom strip shows unseen, abstract instructions, where vision language data helps the robot follow category-level requests. Figure 3 explains why the robot can do those everyday tasks, because the hand itself is designed for dexterity and sensing. This figure shows the full Dexter V2 layout, including how each finger gets 4 degrees of freedom and the thumb gets 5, which expands the range of grasps. The tactile fingertips are highlighted as well, and tactile sensing means pressure sensors that help the robot feel contacts during grasping. The right side then illustrates a strong thumb opposition score, which supports human-like pinches and wraps. Figure 6 explains why the training setup can scale to dexterous hands, because the data come in layers that trade off realism and volume. The figure shows a data pyramid, where robot trajectory data sits at the top as the most on target but hardest to collect, and vision language data sits at the base as the broadest. The middle layers add cross-embodiment robot demonstrations and human trajectory data, which expand coverage when the exact robot hardware is scarce. Figure 8 shows that cross-embodiment training is the difference between decent pick and place and truly robust generalization. Cross-embodiment data means demonstrations from other robot bodies that get aligned into a shared representation, so skills transfer despite different hardware. The top images contrast the basic seen object set with the unseen object set. In the bar chart, GR-Dexter reaches 0.93 in basic, and GR-Dexter also stays strong on unseen objects at 0.85. So, 2 takeaways stand out. The work treats dexterous manipulation as a full-stack problem, where a practical 21 degree of freedom hand and good bimanual teleoperation are just as important as the model. The other big implication is that cross-embodiment and human data can buy real robustness, even when real robot demos are limited. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.